Hello everyone. The title of this video is Factoring a Perfect Square Trinomial. Sorry. Every example I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and I'm in their Algebra and Trigonometry text, section 1.5, Factoring Polynomials. And I'll be under the heading, the objective, factoring a perfect square trinomial. Now, every example I'm going to do is either one of the examples they've shown here, or the try it problems that you'll see, or some of the even numbered exercises at the end of the section that are related to this objective. Now, I do have timestamps for each example I do in the description of the video below if you want to use those to bounce around. And I also request that, when I start a new question, pause the video and try to work it out yourself before watching me do it and comparing. Because if you're just watching me do these things and not practicing yourself, chances are you're not going to learn all that much. Alright, so I got the first example. I got all my examples written out on paper. And, we're asked to factor each polynomial. Or factor means rewrite as a product, right? A multiplication problem or a multiplicative expression. Now the first one is 49x squared minus 14x plus 1. Now this is in that form ax squared plus bx plus c, right? It's in that form ax squared plus bx plus c. So I can try to factor by that grouping method, or something called the AC method. And let's see what happens. Alright, so this isn't what I'm going to talk about in this video. This isn't the main lesson. But I just want to point out that if you have a polynomial in this form, you can always try factoring it through that grouping method that I had discussed in a previous video if you've been following along. And it's also talked about in this section 1.5 of the OpenStax Algebra and Trigonometry text. So that's where I take the lead coefficient times the constant term. Right, so 49 times 1, which would be 49. And then I look for a pair of factors of 49 that add up to b, that add up to negative 14. And those would be negative 7 and negative 7. Right, these multiply to be positive 49, and when you add them, you get negative 14. Alright, and then what I did was I used these numbers, this pair of factors of a times c that added up to b, and just rewrote the middle term. So 49x squared minus 14x plus 1 is equivalent to 49x squared, and then instead of minus 14x, I use this pair of numbers and rewrite it as minus 7x minus 7x. Right, that's the same thing as minus 14x. And then you have your constant term still, plus 1. Then comes the grouping part, where in parentheses I put one group, a group of two terms, the first two terms, 49x squared minus 7x. And then I prefer to do this, I like putting a big plus sign between the groups, plus, and then the next group has the next two terms, which are negative 7x and positive 1. Right, and then you factored out the greatest common factor of each of these groups, right? So 49x squared minus 7x, they have a GCF of 7x. I'd pull out 7x. And what would be left over would be 7x minus 1 plus, and then this second group, remember when the lead of a group was negative, you pulled out the opposite of the greatest common factor. Now the greatest common factor of these two terms would just be 1. They really don't have anything in common other than 1. And because the lead is negative, I factored out negative 1. And if I factor out a negative 1 from this, what's left over would be 7x and then negative 1 again, right? Distribute the negative 1 and you'll get negative 7x plus 1, right? And now look at this. Both these terms, both these products had this quantity 7x minus 1 in common. I pull that out. And if I remove that, the factor remaining would be 7x plus negative 1. 7x plus negative 1 is just 7x minus 1. So look at this. Look at what happens with a polynomial like this. I get the same factor twice. And any expression that can, anything that can be expressed as the product of the same factor twice is a square, right? Remember, anything times itself is that thing squared. So you could express this as 7x minus 1 squared. Alright, so anything where there's the same factor twice is what they call a perfect square. Right, an expression to the second power. And we started with a trinomial. Right, there were 3 terms here. Right, this was a trinomial. So there comes the name perfect square trinomial. Right, in the heading, in the title of the video, factoring a perfect square trinomial. Now this is one way to do it. You can still factor these perfect square trinomials using that grouping method I just showed you right here. But there's an alternate way too. Alright, so let me talk about perfect square trinomials off to the side. Alright, a perfect square trinomial can take one of 2 forms. One is something squared plus 2 times that expression, 2 times a times another expression b, plus, and then that second expression b squared. This is one form a perfect square trinomial can take. And if you recognize that your trinomial has this form, then you should be able to jump right to the factors. Something of this form will factor to a plus b times a plus b again, or a plus b squared. Right. So that's one form, one type of trinomial that's a perfect square trinomial. Or another perfect square trinomial form is a squared minus 2ab plus b squared. If you recognize that your trinomial is in this form, then you can factor it pretty quickly. And this kind of form would factor to a minus b times a minus b, or a minus b squared. Alright, so look back at this first one. Let's look back at this first one. Alright, so instead of factoring it by grouping, one thing I'll say is, you're given a trinomial, and you put it in descending order by power, square, then first, then constant. If you notice that the first term is a perfect square, right? 49 times x squared I can express as 7x to the second power, 7x times 7x. And this constant term, plus is also a perfect square. 1 I can think of as 1 squared. So if the first term is a perfect square, and the constant term is also adding a perfect square, then you might have one of these. All right, it all depends on that middle term. Now look at the middle term. If I think of 7x as a, right, so this is a squared, and think of 1 as b, right, so this last term is plus b squared. If that middle term is the form minus 2 times a times b, then I have a perfect square trinomial. Well, let's see. Is that minus 2 times a, times 7x times b, right, times 1? Is that true? Yes, it is. Yes, it is, right? The middle term is minus 2ab, right? So we have a squared minus 2ab plus b squared. This polynomial is a perfect square trinomial. And so I should then be able to factor it very easily to a minus b, right, since it's in the minus 2ab form. A minus b, 7x was a, minus and b here was 1. Should factor to a minus b squared, which is exactly what I got earlier, right? I got the quantity 7x minus 1 squared when factoring, with that grouping method earlier. Okay? So if you recognize, right, that's the tricky part, you have to recognize that your trinomial is in one of these forms to be able to factor it real quickly. Right. If you don't recognize that, then you'll probably have to go through and resort to the grouping method, right? Or guess and check, but I don't like guessing and checking. All right, and now of course we got to check our answer. Right? Always check your results. I'll show you a couple ways we can do this. First, you multiply, right? Take our final result here, right? 7x minus 1 squared. Remember what that means. That means 7x minus 1 times 7x minus 1. And then you got to FOIL, right? You got to distribute the 7x to the 7x minus 1 over here. So that'd be 49x squared minus 7x. And then you distribute the negative 1 to the 7x minus 1. You got minus 7x again, and then plus 1. And combining the like terms, you got 49x squared minus 14x plus 1. And this is the original expression. So that means we did a good job. All right. If you multiply your final result out and get the original expression back, that means your factorization was good. All right. Or you don't know how to multiply and you got it wrong, but you multiplied incorrectly and said, oh, look, it's the original. Right? But chances are, if you know how to multiply, you know how to do things properly, you did everything good. Right? You did everything well. Now also, something else I want to point out. The only way two expressions are equivalent, so I'm saying that 49x squared minus 14x plus 1 is equal to the quantity 7x minus 1 squared. Right? The only way that two expressions are equal is if they're always equal, right? They're equal for any value of the variable. So you can replace x with any number you want, and both of these will be the same value. Now you can do that by hand with a couple values of x, replace x with 0, and you'd get 1 equals 1, replace x with 5, 2, whatever you want. Now I'm going to do this with multiple values on a calculator. All right, now I'm going to do it with a free online graphing calculator. This is at desmos.com. It's free online graphing calculator. And off to the side here, I'll put my first expression. That was 49x squared minus 14x plus 1. And then in the graph, I mean, they're graphing y equals, this is the x-axis and y-axis of the typical Cartesian plane. That's that green graph that just showed up here is the graph of y equals 49x squared minus 14x plus 1. But I'm not going to put the whole y and everything. All right, then the other expression, right, what we ended up factoring it to was the quantity 7x minus 1 squared. And you see that that graph is right on top of the other one, green, purple, right? They're the same graph. So that means they have the same value all the time, right? No matter what you plug in for x. And you can also verify that with a table, right? If I put up a table for both of these, see how they look exactly the same? You'll see when x equals -2, both expressions have a value of 225. When x equals -1, both expressions have a value of 64. And so on, right? And you can plug in other numbers if you wish, but you can get to believing that these expressions are truly equal by, now this is, again, this doesn't prove that they're equal. It just gives you a feel that, hey, these are probably equal because they're the same value no matter what you plug in for the variable. All right, the way you got to truly prove it is actually by multiplying it out the way I did earlier. All right. Okay, but please don't forget to check your results. Okay, next question. Again, I'll do this next one in both ways as well, where again, I'll show you, you can factor it by grouping if you want, and you'll see that we get a perfect square at the end, right? Some expression to the second power, the same factor twice. And then I'll show you, like, instead of doing that, we could have just, hopefully, we could have just recognized it as a perfect square trinomial. All right, so number 2. So again, first I'll do it with that grouping method. We have 16a squared minus 8a plus 1. I take the lead coefficient times the constant, right? 16 times 1 is 16. And then I'm looking for a pair of factors of positive 16 that add up to -8. And those would be -4 and -4. And also, you may have noticed this in number 1. That pair of factors, if it's the same factor twice, then you've got a perfect square trinomial. That's another way to tell. All right, so I could stop right now and be like, ooh, this is the same factor twice. This must be a perfect square trinomial. All right, but I'll continue. So this is equal to 16a squared minus 4a minus 4a. All right, and then plus 1. Then I do the grouping. Right, first 2 terms in a group plus the second 2 terms in a group, -4a plus 1. Factor out the first group would be 4a times 4a minus 1 plus, and then the second group, has a greatest common factor of 1, but the lead was negative, so I'm going to pull out the opposite of that, pull out -1, and then you'll have 4a minus 1 left over there. And I end up with 4a minus 1 times 4a minus 1, or 4a minus 1 to the second power, right? A perfect square. A perfect square. And I'm done. I mean, that's all they asked me to do is factor it. But, if you look at this and say, hey, the first term is a perfect square. 16a squared is 4a times 4a, right? 4a squared. The constant term is a square, right? Plus 1 squared. So if I think of 4a as the capital A and 1 is the capital B, is the middle term minus 2ab or plus 2ab? Because if it is, then we have a perfect square trinomial. We have something of one of these forms. All right. Well, let's see. Let's go minus 2 times 4a times b is 1. Is this -8a? Absolutely. These are the same. So this is a perfect square trinomial. This is in that form a squared minus 2ab plus b squared. And you should, again, if you have these memorized, it'll make it a lot quicker. This would factor to a minus b times a minus b. or a minus b squared. So this will factor to a, the capital A was this 4a, minus b, which was 1, to the second power. And again, I get the same thing that I got by factoring by grouping. Wonderful. All right, so that's what I'm going to do with the next ones, right? You can factor all the, you can factor all of these by grouping. But if you recognize right away that it's a perfect square trinomial, it'll just be able to be factored that much faster. All right, and once again, don't forget to check your result, right? Take 4a minus 1 and multiply it by 4a minus 1 and see that you get 16a squared minus 8a plus 1 back. And you should. Also, you can verify that this expression that I started with and this expression that I ended with, they should have the same value no matter what you plug in for a. But I'll leave it to you to test that out. Alright, so this time I'm going to look at this. I got a trinomial, right? It's 3 terms, trinomial. And I'm noticing that, the first term, 121x squared, that's a perfect square. That's 11x times 11x. Right? That's 11x squared. The last term is a perfect square, plus 4 squared. All right, so again, I'll think of this 11x as the capital A, and this 4 as the capital B, and we got a minus here. So I'm trying to think, I'm trying to see, is that middle term minus 2ab? Right, question mark. Is the middle term minus 2 times a times b? Well, let's see. Let's go minus 2 times, I'm calling a 11x, times b I'm calling 4. This is negative 22x times 4. That is negative 88x. So this is a perfect square trinomial and can be factored very quickly. And we saw that this is in that form, a squared minus 2ab plus b squared, where a is 11x and b is 4. So this factors to just the quantity a minus b squared. So 11x minus 4 squared. And I'm done. And if you want to check it, pardon me. All right, don't forget to check your work. You would take 11x minus 4 and multiply it by 11x minus 4 again, and then see if you get the original expression back, and you should. And once again, you can also verify that these have the same value no matter what you plug in for x. Right, but I leave it to you to check that stuff. But you should always be testing your work out. Great. All right, so number 4, same thing. I've got 3 terms, a trinomial. The first term is a square. It's m squared. And it's obvious. The last term is plus, 10 squared. All right, so I'm going to think of m as the capital A and 10 as the capital B, and then ask myself, oh, this might be a perfect square trinomial. Is the middle term, it's a minus here, so is the middle term minus 2ab? Right, question mark. Well, let's see. Do minus 2 times a, which is m, times b, which is 10. That's minus 20m, which is what this middle term is. So check on that. This is a perfect square trinomial. Excellent. Right? If this middle term wasn't the same as this middle term here, then I would say, oh, it's not a perfect square trinomial. And then I'd have to try factoring it by grouping or some other way. But it is a perfect square trinomial. And yeah, a squared minus 2ab plus b squared, that's going to factor to a minus b, m minus 10 to the second power. Or m minus 10 times m minus 10 again. There we go. And don't forget to check, right? Always writing this, always check your work. take m minus 10 times m minus 10 again, and see that you get m squared minus 20m plus 100. And you can also test that these two expressions are the same value no matter what you plug in for m. Great. Alright, and then this is the last example. So again, I got three terms. Now again, you can try factoring it by that grouping method because it's in that form a variable squared plus b times a variable plus c. But if you notice that the first term and the last term are perfect squares, right? 36q squared is 6 times q squared, right? That's 36q squared. And the last term is positive, 5 squared. So I'll call 6q the capital A, and then the positive 5 the capital B. And then, so you might think, oh, this might be, because the first term and last term are a perfect square, this might be a perfect square trinomial. So now the question is this middle term plus, right, because it's a plus in the middle now, plus 2ab? And let's see, ask that question. So we go plus 2 times, the 6q was what I called a, and then b was 5. That's 12q times 5, that's 60q. This is 60q, so yes, this expression is a perfect square trinomial. And once again, if this didn't work, if this 2ab wasn't the middle term, that means it's not a perfect square trinomial, and you got to try something else. All right, and we have this form now, right? A squared plus 2ab plus b squared, and this will factor to a plus b to the second power. So this will factor to, a plus b, 6q plus 5, the quantity 6q plus 5 squared. And there you go, totally factored. And again, don't forget to check your work. Take 6q plus 5 and multiply it by 6q plus 5. And you better end up with 36q squared plus 60q plus 25. Also, you can try to verify and test out that this expression I started with and this expression I ended with, they will be the same value no matter what I plug in for q. And I'll leave it to you to check that out yourself. Alright, and that's it. Alright, so I'm hoping that watching me go through these 5 examples helps you in some way when you're asked to factor a perfect square trinomial on your own. And thank you very much for watching.